In a world where conversations about AI dominate almost every corner, there's another field that's been quietly emerging: longevity. As longevity, aka aging science, garners interest from tech tycoons and investors, alongside scientists, we invited Maximilian and Unfried to help us better understand this fascinating domain. Max, currently affiliated with the Center for Healthy Longevity at the National University of Singapore, conducts research at the intersection of aging biology, AI, and complexity science, aiming to decode aging's molecular mechanisms. And he is also an active member of Vita DAO, a crypto community dedicated to funding aging research.
So thank you for joining us. And first of all, can you tell us a little bit about your background and what were the circumstances that you started to work on longevity, and a little bit about your start?
Sure. So I'm currently mainly a scientist. But I think how I got into longevity was because my English teachers at school were not good enough to teach me English. So I'm originally German, and I almost didn't get my A levels because my English was so bad. And then when I started studying science, I first did like biophysics and biomathematics and molecular biology. I realized when you want to have a career in science, I really have to improve my English, and figured, hey, what is a good way about learning that, especially if you want to get into biological English. So I looked at books that might be useful, and I tried to order one book from Amazon that was like How Animals Have Sex. I thought, okay, that should be simple enough, right? And then Amazon recommended me a book that is called Ending Aging by Aubrey de Grey. I thought, okay, that sounds interesting, whatever. So I bought that book as well. And after reading the first book and now Animals Make Babies, I took on the other book, which was like way harder to read, and it dealt with like, hey, there's this thing called aging and we probably can do something about it. And it was like a very hard read, especially, I mean, I was literally sitting there with like, it must have been in 2010 or 2009. I was sitting there with like pen and paper, a dictionary next to me, reading those books and writing down the words I didn't understand and looking them up, what they mean in German, and building up my vocabulary. And I guess that was like somehow experience that aging biology never really left my mind after that. And I always had it in my mind. And then once the time came to pursue a PhD, I figured that's a cool avenue. And I also rationalized that like if I spend 4 years on a PhD studying aging and I am able to learn enough to extend my own health or lifespan by 4 years, I'm like break even, and the time wouldn't be wasted. And that's how I kind of ended up in the aging field.
So can you tell us a little bit about this field? Because perhaps like as you at the beginning, our people also may not know much about longevity. Just to give a background, like, what did you learn?
So I think to be fair, the rebranding into longevity, I'm not a big fan of, because it's like just way too ambiguous, right? Everything is almost now longevity, right? Everything that somewhat extends your lifespan, independent of mechanism. And originally the idea was more we should target the aging process directly. So currently, what we mainly do when we develop new drugs, we target symptoms, right? We try to cure cancer. We're not trying to actually prevent cancer. We're trying to cure Alzheimer's disease. We're not trying to prevent Alzheimer's disease, right? And the idea behind what now is called longevity is the idea that aging is the root cause of all those age-related diseases. And if we could stop that or delay that, then those diseases wouldn't be there to begin with, because usually young people don't get Alzheimer's, they usually don't get cancers, they don't have cardiovascular risk, right? Young people don't just die, right? The mortality for like a young person is entirely different than the mortality rate like for like an old person. And the idea is like, okay, when we can modulate and get control of the aging process, those diseases don't occur. We don't have to deal with the symptoms anymore. And also the idea is that almost the aging process of all those, or like for all those diseases, they are different to each other, but the root cause, aging being the same one, also means you only have to target one problem instead of like fighting like a hydra where you have like a bunch of different problems for each disease that you have to overcome.
Okay, so you don't particularly like the aging kind of term or the name, but I guess for the purposes of this conversation, probably I will be referring to longevity. Longevity field. What is the overall composition of this field area? So who are there are scientists working, but it seems that there are startups cropping up. So who are the main stakeholders? How does this look in the US, Europe, Asia?
So, I mean, I think it's still very heavily depending on academia. And that is like 20 years ago, people would have told you're crazy if you talk about targeting aging, right? I mean, there was like just when like the first discoveries were made that you can like create mutants that live longer, like than 15 years ago, that they're like small molecules that extend lifespan and whatnot, right? So it became more popular, right? And obviously all those things take time. And now it's the time where now there's like more hunger and more startups are being started in that space. So what the research that has happened the last 2 decades in academia, some of that's like now slowly coming out and be able to be spun out into companies. Now we can use them to develop novel means of therapeutics. So I think there's like slowly like a shift happening. At the same time, I think academia still plays like a massive role. And even if you look at a lot of universities, they all now start somewhat rebranding and have now a center for healthy aging, a center for longevity, a hospital for longevity medicine, right? So I think slowly like the universities like rebranding into that and trying to get talent and shifting their focus a little bit in towards more aging research and longevity. And to be fair, that also like I think depends a little bit on the region. I think obviously US and Europe has been on that front a little bit longer, right? In the US, you have the Buck Institute of Aging for like 15, 20 years. In Europe, you have like a few institutions in academia that are already around for longer. In Asia, you have like a few that are like more like 5 to 10 years now, but more cropping up. So I think there's like an entire shift that institutions are changing. And then you also have now venture capital and investors and financiers going in this direction, right? That you have like more, not many, but it's definitely growing. Like I guess like 10 to 15, maybe 20 venture capital funds that purely focus on aging and longevity. They don't want to do normal biotech. They really are like on the mission and say, hey, we want to do the hard stuff. We want to fund like novel modalities of how we can develop medicine. So yeah, I think that's this ecosystem is like growing and evolving as we speak.
But is it like, okay, so you touched upon venture capital. Is this like for VCs, is this really the risk already? I mean, in a sense, like these kind of things, they take time, right? R&D, right? So it takes a lot of time. So I don't know, like, yeah, financiers may want to get into this, but do we, or I guess the question may be, is there commercialable research that could be turned into, I don't know, products or therapeutics things?
I think so. I think here's like, I think what probably matters, anything in biotech is super high risk anyway, right? Even traditional biotech, 90% of it will fail. So even now, if you go like towards more ambitious goals, I would claim the failure rate is probably not going to be much different of that, right? Given that it's already that high. Yeah, I think there are like certain therapies that are like being tried out that are getting a lot of money, right? That are getting more popular. Some of them are like already like listed on the stock exchange, right? I think Unity Bio who was like working on Senolytics, IPO'd like a few years ago, which is like working on like senescent cell removal. Then you have like more money flowing in, especially like from people. For them, it's probably more now. I have a lot of money now. I want to have like more health and more life, right? And that's maybe not purely financially motivated, but also like, well, okay, somebody has to lift like be the wave that lifts all boats and start with that. And I mean, you see, I think Altos Labs with like $3 billion a few years ago was like the best funded startup ever, right? Then at the same time, a lot of due to regulations, a lot of those companies they want to do aging, but as the FDA and other regulatory bodies don't accept aging as a disease, right? They have to, in a way, find like kind of loopholes and say, well, we want to do aging, but we kind of show that it just works for like a certain disease now. But we are confident that when it works for those diseases, it will also be preventive of all the other diseases, and then you can branch out, right? And it's almost like another way of thinking about it is that like in the past, when you developed like a therapeutic for one disease, one indications that's what you went after, and you didn't actually have much hope that this could be reused for another indication, right? With aging, it's now, well, okay, you go for one indication, you spend the same amount of money, but now you probably have like 10 other indications that it can also be used for, and that therefore you have like a much larger market. So while the risk might be like a little bit higher, the proportional gains are like even higher now as well, right? And that's just looking at numbers starts making sense again.
But do you think that there is like kind of one therapy that would kind of solve this aging problem? Like, is it realistic? It's like one bullet that you use and then you solve all this. Because yeah, this is the promise, right? That basically you target aging and then you solve like all other diseases like yeah, cancer, diabetes, and so on. But how realistic is it?
I think it won't be one pill, right? It won't be like just one injection or something like that, right? I mean, we know that different parts of the body age differently for different people, right? And certain parts of your body might need an earlier fixing than other parts. So it probably will be like a combination of various therapies, right? And I mean, you even see that currently at normal diseases, right? Normally, it's not you just get one drug per disease, right? It's usually like it's like cycles and combination of drugs and whatnot.
Yeah.
So I think in the realm of what most people currently think, it won't be like a one thing cures it all. I think there are like a few more exotic approaches, which might be that, and that goes towards the concept of like full body replacement, right? It's like, well, okay, we just like take your DNA, we grow a new you, and then transplant your brain or like something along those lines, right? That's obviously like almost like it's not an entirely different area. It still has like the same goal of life extension and health extension, but it looks at it more like an engineering problem, right? And there you could see you wouldn't have to solve all those independent small problems, right? It's you have like to solve one problem. It's like cloning and surgery. Um, um, and it's a different approach. I think it's exciting. Some people are slowly pursuing it. It's still like I think an idea that is like a little bit unconventional and maybe a little bit controversial. But yeah, we have to try out if we really want to get serious about like radical life extension.
And what is your approach? What do you think is the most realistic part?
Um, for me, that always goes in waves. There are like weeks where I think, oh, well, in 10 years we figure that out. And then it's like the next week is like, oh shit, it's gonna take like another 50 to 100 years. Um, um, I, I do think that probably both things will like play a role. That like I think it's like just exciting of like learning more about like biology and figuring out like how all those molecules and genetics and epigenetics works, right? And how we can tweak them. That probably helps us for sure, like to live longer and healthier. But the question is, does this have like a cap at some point, right? We currently don't know what the maximum human lifespan is. And some people might make the argument, even if you fix all the damage and all the problems, there's like still something in your gene that eventually will kill you or make you not function anymore, right? So the way I almost look about it is like maybe the next 30, 40 years, we will probably still rely more on like the normal biotech approach to get like everybody to 120, and maybe then technology for like replacement of whole bodies and body parts is there that we can then like switch to that modality. But then also I think even that modality will probably then benefit from what we learned from the normal biotech space to implant enhanced organs, right? It's like the idea is almost you're now old, you have like bad organs, but you don't want to have an organ implemented that's only as good as your youthful one. You want to have like an organ that is 10 times as good as an original one or something like that. And that still has them to be grafted, right? It's like then this organ that is 10 times as good could age 10 times slower or something along those lines and be more resistant and thereby you get like another boost. So I think it's, I mean, like with everything is connected in biology, but also outside of biology, everything is connected and one technology elevates the other technology.
This kind of reminds me like all these enhancement things. When do we actually want the same body? Because yeah, our body is flawed, right? In a
Yeah,
way.
yeah. I guess everybody is flawed at some point, right? Even if you could create your best body that you would imagine and can imagine, there's probably still some flaws in there. Um, uh, I think it's yeah, I think flaws are fine.
I don't know, it's kind of depends how you look at it, right? Because yeah, our bodies are kind of flawed, but on the other hand, they are really amazing. So yeah.
Hmm.
But can you talk a little about actually some of the advances or like what excites you in this field or what is really, it seems because you said, okay, some days I feel like, okay, it's gonna work out soon. Some days it's like, it looks like very long-term kind of goal. What have you been excited about actually?
Um, I think that like you mean personally me exciting seeing the progress or new science being exciting or
About the
exciting
advances, specifically
Mhm.
the recent advances that could lead to actual applications quite soon.
So I think people starting to be more creative and realize that like only dumping small molecules in in a complex organism won't do much, right? So I think what I think is interesting is like a mitochondrial transfers and replacements. So the idea is, well, you have your cells and the mitochondria age. Could you somehow produce new mitochondria externally and inject them, and new mitochondria will go into your cells and keep the power plants younger. I think this is, and a few years ago, people started doing that, and now there are more groups working on it. I think there are like still like a few controversies, but I think it's like an interesting approach. Just okay, just in a way, it's organelle replacement, right? Let's replace like things within the cell. Um, then I think replacing fluids might be like a lower hanging fruit than replacing full organs, right? Just imagine, okay, whatever, once a week you get your full blood renewed or something like that, or like your spinal fluid, or your lymph, right? And uh, there's like some data, at least like in mice and rats, that shows like that parabiosis like experiments seem to be good for the health span of the animals. We don't have fully done the experiments in humans yet, but I think people should try it out and people will try it out to see what if like blood replacement can keep you younger, right? And that seems also something also like where you don't have to fully understand how it works as long as it works, and then it's almost like just more an engineering problem, right? It's like if you go like to dialysis and you have to be plugged in there anyway to get your blood cleaned up, might as well just replace it. And obviously the main question is where do you get all this new blood from, right? I mean, we still haven't solved the problem of okay, can we generate artificial blood in large quantities, right? So it's not that easy, but I think it's interesting. Um, what else is out there? I think probably like also like immune cell rejuvenation, be it like through reprogramming or other things, like where you whatever take your immune cells out and like do some things with them that seems to make them younger again, and then inject them again, and thereby like boost your immune system. I think is like a cool approach. Um, some people work on something similar, like going more like from stem cells. That's probably promising. Um, yeah, and I think there are like cool things coming up. Um, that's like just that, I think there are a lot of things going up, but those are currently my favorites.
And talking about intervention, so out of curiosity, what is that point of time that is the best to intervene? Like at what age would you say people should start these interventions? Do they have any research on that? Like, yeah.
I have some thoughts on that, and it's I think there's like when people talk about longevity interventions, they mean different things. And to maybe make it very simple is like there are like probably interventions that can slow aging, and there are interventions that can rejuvenate. And those are probably two different modalities, right? And I mean, I've ran some simulations, and what you can see is like that slowing aging is probably mostly effective the earlier you start, right? Because I mean, it's almost like building, it's in a way slowing something like building up the damage, right? And the less damage you have, the less damage you will build up, and the slower you age, and that's good, right? If you only start those slowing aging interventions very late, where you already have a lot of damage, probably not that efficient anymore, right? Still does something, but ideally, I mean, you start them probably in your prime. Like on the day you're in your prime and you want to be there, that's probably like the best way to go about it. Um, then on the other hand, I think you have like those rejuvenation interventions where the idea is more like, well, you give them once every 6 months and they put your entire body or your entire organ back to a level that is more useful, right? And I think those are like the things that probably like you almost age independent, right? It's like I think that definitely will work better when you're old, right? Because I mean, when you're still young and everything is young, there's like no point of rejuvenating it, right? But I think yeah, those things probably almost age independent. You can start them and they bring you back to that level. And there's probably the combination of both, right? It's like whatever once you start rejuvenation and then probably you can slow aging. That's also like a good thing. But to be fair, I mean, I think most things that are like currently being added or like being ha- hailed as like not miracle drugs are like probably like more in the regime of like slowing aging, right? I mean, that's I think even where like a lot of those things or even normalizing aging, where like things like exercise and good sleep and healthy lifestyle falls in, right? That probably just like builds up less damage, so that slows aging. But then like small molecules like whatever rapamycin, metformin, whatnot are probably like more slowing aging. And then I think those rejuvenation therapies. Um, uh, they're still being developed. I mean, the closest thing that might be out there are like some follistatin gene therapies, but I think the full verdict on those is out as well. There's like still a lot of more anecdotal evidence that it really works well, but we don't know what it looks in the long term.
Is there in the community among researchers, is there any consensus like kind of the lifestyle factors that you kind of now just mentioned, like sleep and diet, versus really taking any like molecules, medicines? What is the kind of proportion? Like, do lifestyle factors, are they playing just minor role, major role, or do we know about that at all? Is there any kind of research on that?
No, I think the boring answer is, I mean, we all know that a healthy lifestyle is better for you, right? And that's a good foundation, right? And it's currently your best bet given that's actually all determined on you, right? So I mean, getting like your a good amount of sleep, having like a balanced diet, getting your movement, avoiding chronic stress are like certainly won't hurt you, right? And that being said, I think especially when it comes to diets. Um, or like not even diets, but like diets and fasting, that what might be good for one person might not be good for another person, right? So I think that becomes like a little bit almost personalized, and there's like no size fits all, right? And I mean, you see it even independent of like aging, right? I mean, you have like the the carnivores claim they're the healthiest, the vegans claim they're the healthiest, the vegetarians are somewhere in between, and so it's I think this entire diet debate, um, a healthy balanced diet is probably good. All those fats that are people trying to make money off of are like probably not the best. And then when it comes like to those small molecule interventions, what is currently discussed is like if you already live super healthy and you have your good diet, you do your exercise, your sports, do those things still give you like a good benefit, or are those trucks more like for lazy people that don't do sports, and that's why it helps them, right? I mean, some of them seem to be like acting on similar mechanisms, like fasting or exercise would be right. So, and once you already do exercise, those trucks don't do much anymore for you.
Exactly. I guess I like what I actually wanted to ask because, of course, we do know what is good for us, like
Yeah.
eating healthily and getting enough sleep, but we don't always do that. And like, I bet if there's like one, tablet that people can take to live kind of healthier. So, of course, I guess mentioning this anecdotally, like jokingly, but people are kind of lazy. So I guess if someone will develop, of course, probably not going to be one drug, but like a set of interventions. So people probably will be flocking to that because it's so easy and like, okay, now you don't have to do anything.
I mean, you see that with Ozempic, right? Like the weight loss drug. It's like that's the reason why it's a bestseller, right? Everybody's injecting it, and everybody's happy that they're losing weight,
Yeah.
right? And so maybe we solved obesity. Good. Now we only have to solve like sleep and muscle, I guess. And maybe that's one way of going about it, right?
Yeah. But again, I think that this is not going to add that much of years for you, even if you do, like, I don't know, you sleep well, eat healthy, like perhaps we are talking about additional, I don't know, 10 years, but
Yeah.
definitely not, uh, what you were saying about 200 years and so on.
Yeah, probably not. No.
Yeah. And also there are like environmental factors like toxins, air quality, right? All those things also do matter, although people focus more on the diet or sleep.
Oh yeah, absolutely. I mean, like the environment is crucial on all those things. The thing is, it's super hard to quantify, I think, how much it matters, right? I mean, it's like I think most of those things, when people study those, it's almost always socioeconomic status that plays a role, right? It's yeah, sure, you have money, you live like in a nice area where the air is better and whatnot, right? And you live longer, and it's like yeah, good. You can also afford all the better doctors, the better food. So it's always like super convoluted. And then I mean, how much can you realistically do about microplastics or hormones in your water, right? It's like this is very tricky. That's I mean, people say it's like not realistic that everybody will exercise. Well, try everybody not drinking water anymore that comes out of your tap, right? And I think obviously people like making or like putting like more effort onto that. Um, and then obviously like all those processed foods, right? I mean, there's an argument to be made. Maybe we should all just take on the big food industry, right? And say, don't fire all your biochemists that try to produce nutrients, right? And just produce normal food, right? And maybe that would help, right? Um, but also, I mean, that's obviously only will add you a few healthy years, right? Let's eat again like it would be 100 years, maybe 80 years ago or so, right? And that's obviously that's more like a problem of culture and society than biotech. The other thing is probably the idea as well. We could do all those bad things, but our medicines are just so good that it doesn't matter, right? We can take all the toxins in the world, and our new drugs just like will take care of it. I guess that might be the more realistic scenario.
Yeah. So do you think also that all these new interventions is basically for the rich? Because yeah, you already mentioned about the food and like nicer place where you live. That's true. But also like about the healthy aging and all these new interventions, because I imagine that they would be quite costly. So it's definitely not for an average person.
I don't know. I mean, they're like, I mean, those small molecule drugs, right, that give you like a few healthy years, they're all like almost generics by now, right? I mean, they cost a few dollars. So that's cheap for medicine, right? So they are affordable. They're already a lot of people use metformin for diabetes, right? So it's like not a stretch that everybody, well, I'm not even sure if metformin is it's not a good example. I'm not that big of a fan of it, but just to make the point, right? Like
Yeah.
repurposing drugs. that give you a few healthy years might not be a big thing, right? And then the question is, well, currently, if you have cancer, I mean, at least in Europe, right, and you have your insurance, you get your cancer treatment paid, and that's very expensive. I'm not sure if those other treatments, longevity interventions, will be more expensive than cancer treatments, right? And if people can afford cancer treatments, then like, uh, yeah, or if they can get cancer treatments, they should get also like those longevity and aging interventions. And with that being said, probably given that there's in the long term, it's probably cheaper for an insurance to have those interventions that keep people healthy, right? It probably should be even easier to get it. Obviously, that's like all those financial mathematicians have to figure that out, what the right and fair pricing for that is, right? Um, but I actually think it probably would be less for the rich than the current medical system is.
Yeah, but I guess also just to echo in a way what you did, I said, there's one thing I would guess there are those low-hanging fruits, what you described, like people take different medicines and so on. But it seems what is happening a bit now, like all those kind of longevity clinics are opening up. Like, so I recently read one basically article. There's new clinic opening up in Sweden, I think, backed up by Spotify kind of founders and so on. So that looks like something really just for the rich, because you're gonna go into that clinic and get like really kind of holistic kind of scanning of your body and different like measurements taken. And yeah, like I guess I couldn't afford it, and like many people, like normal people couldn't, but only like wealthier people could. So I guess this is like, yeah, kind of in a way inequality, right? Or like maybe the cost will go down in the future, but at least not for now, probably.
Yeah, I mean, I think the real question there is why is not every normal doctor doing that, right? I mean, that almost should be that should be the standard of care. That should be standard medicine, right? Preventive medicine. That's what almost I think every doctor almost like swore an oath on, right? But the entire system just like went in the wrong direction. And I mean, to be fair, sure, I mean, those things are expensive, but I mean, concierge medicine concierge medicine has existed prior to longevity medicine, right? There has always been like private clinics where people can go to and spend money on things that probably work and spend a lot of money on things that probably don't work. Um, and then there's obviously like also like naming and branding. It's a business, right? But yeah, I think it's like I said, I mean, those things might with every technology start expensive, but then become cheaper, right? Because then at some point people will say, hey, why do they get it if it helps, and why don't we get it, right? And there's like even like other things to it, right? There's like certain treatments that are like even non-risky treatments, right? That like are not allowed because they're in the US are not FDA approved, right? And then you can go somewhere else and try it out, right? And the other day I went to a clinic and um, I'm not sure if this device worked or not, but it seemed to be nothing harmful, right? They claimed they could like to like some kind of magnetic interference, they could like shrink cancer cells. That doesn't seem like that would be anything damaging to you. There seems to be some science behind it of like um, uh, exchange like of electrolytes in the cells, that cancer cells have like different distribution on them, and to whatever their magnetic wave they can block them, and thereby they explode. Whatever, right? That's stuff. Why shouldn't we not able to be tried it out somewhere, right? And currently those things can only be tested in private clinics. Um, and always that benefits everything in the long term, right? If it works out and people start talking about it. And that's currently just not possible in the medical system in Europe or in the US.
Also, do you think that some people self-experiment while like enthusiasts of this longevity something that, yeah, perhaps it's not approved, but I mean, if, yeah, as you say, if it is something easy, perhaps people also like do it themselves.
Yeah, absolutely. People do that. And I mean, that's where probably like the biohacking space with like the longevity space somewhere interacts, right? Um, and sure, I mean, there are like places where you can get certain things done. Um, and people test it out and they say, that's my body, it's my choice. And they take a certain risk on, and let's see what the future holds. I mean, the funny thing is that is so controversial. That used to be what scientists used to do, right? A lot of our big interventions that are like the findings that we made in science, the doctors try them out first, right? Um,
Yeah, that's
so
true.
it's,
Yeah, but yeah, so I totally agree. Like people, like scientists experimenting with themselves, but they kind of were doing it for the site. Well, yeah, it's depending how you look at it. Of course, I don't know the space, but it seems that there's I don't know, maybe quite a few people or some people who are trying out stuff and it, maybe sometimes without realizing that there might be consequences actually, because yeah, some stuff is just untested or yeah, just self-experimentation.
I mean, I think people are aware there are consequences potentially, right? But it's like with every frontier that somebody has to test it out, right? I mean, the first people who went like to the North Pole or South Pole, it's like just a certain amount of personality that you need to do that, right? And I think it's the same like now that we explored everything geographically on land. The next thing is exploration of like the internal molecular world and see how you can tweak it, right? Um, so I always think kudos to those people who tried it, right? And it's almost like yeah, be the guinea pigs.
Yeah. And do you know any examples of something like what people report, like how those experiments go for them?
So and I think probably like two examples are like certain peptides. And I think that's not even necessarily in the longevity space. That's almost like in the sports medicine space, right? For like all those extreme sport people, like I think it's TB 500 and TBC 157 that has some data on rats against inflammation and whatnot. And it's currently became popular that people use it for injury, but also inflammation, gastric inflammation, joint pain and whatnot. And I know that like some longevity physicians probably would make recommendations on that, but that to be seen, there's also like a broad spectrum on longevity physicians. It's like there's some like more conservative ones and the ones that are like maybe came from sport medicine that are uh, that are like more open to experimentation, right? And obviously you have your own client base. And then I think what probably gained more popularity recently is like the follistatin gene therapy by Minicircle that you can get in Vitalia in Roatan and Honduras. I think they had like a couple of hundred people by now using them. Um, I think they finished up a clinical trial. They're currently preparing for the publication. Um, I mean, people write about it on Twitter and say, "Hey, this is my measurement before and after," right? And a lot of people say, "Hey, my energy is better, my blood lipid is better, inflammations marker are better, I have more strength," and so that's all like goes in or signals in a good direction. At the same time, obviously, what we don't know, what is the long-term consequence, right? I always think there might be a set of therapies that increase your health span, but you compromise on lifespan. And maybe that's what a lot of people actually, I talk to physicians, but that's what most people want, right? They probably prefer living to like 75, but be super healthy than like to 80 and from 65 on, it's going to be bad, right? Um, um, Ideally, you probably want to have both. And obviously in humans, we also don't know that yet. Um, but I think there's like the potential of that we just can't anticipate all the long-term effects.
Yeah, I think that's a very good point because definitely I don't think that it's, I mean, you don't want perhaps to live 250 years, but yeah, if you are not active, if you cannot do things that you can, yeah, you can usually do. So I think that's like a very important thing. It's not only about the years, but like how you actually feel during those years, right?
Correct, yeah. I guess most people, unless you're like some weird form of
Yeah,
masochist who wants to suffer longer,
yeah,
um, it's probably, yeah, people want to live longer, healthier.
You were mentioning lipids, and I think your own research was about lipids and biomarkers, right, of aging. Can you talk about that thing and what you found? What was interesting there?
So sure, I think there are like a few interesting points. I mean, most people when they think about lipids, they think about cholesterol, they think about fatty acids, triglycerides. They think about all the wiggly stuff on your body. They think about like all the things for like increased risk of cardiovascular disease. And that's all true, but that's like a very limited view on lipids, right? I mean, there are like 400 other different classes of lipids that are like not getting that much attention um, yet in medicine, let's say like that. And one reason is that given the structure of lipids that are very hydrophobic, they are way harder to measure. And technology wasn't there 10 years ago. And so technology has become better now. So like we're like able to measure like a couple of thousand lipids in your blood. And now the idea is, okay, we should analyze them, given that some of the biggest drugs in history are like lipid lowering molecules. Given that like so many other more molecules, so many other more lipids, maybe we can find new drugs to target them in one way, right? And what I've been working on is like on lipid biomarkers of aging. So the idea is like other aging clocks. What kind of lipids are relevant for aging? How do they change with age? And do they have predictive power on giving insights in your body of how you're actually aging? And there are like a few lipid classes that really stand out. It's like sphingolipids and ceramides and sphingomyelins. And those are like lipid classes that are in the literature have to be found to be associated with like human longevity, with centenarians, with uh, various diseases and health outcomes. And that becomes a little bit convoluted because like some of those lipids are like protective, some other ones are like more like something like death lipids. The more of them you have, the worse. So I think it's like an ongoing area of research, but I think people should start looking into lipids more and how they can be used. As therapies, but also as like finding novel targets. And one thing that I'm currently thinking more about is like, especially like lipid bilayers, right? I mean, if you think about at the origin of life, or we wouldn't be there if like cells wouldn't have membranes, right? If you wouldn't have this compartmentalization, um, we wouldn't exist, right? So it's almost like at the very beginning, we started having those bilayers, and they change with age, right? And changes mean they become more stiff, but it also means they become more permeable or not unpermeable, right? So more things get in that probably shouldn't be in there. Certain things that probably should inside go out. But then it's also like all the anchoring of the proteins and receptors and channels, right? That changes a little bit. So that probably makes like a cell that's not functioning that well anymore. So I'm currently thinking how could we actually target plasma membranes and cell membranes to keep the integrity up over during aging. Um, that's currently what excites me. I think this is like it's funny because in the past people looked a lot of membranes and people started understanding them, and then everybody probably got like their publications out, and then it was not a hot topic anymore. And I think slowly lipids are coming up again. So I think science goes always in cycles. And I think slowly more people start looking at it again. And I think it makes sense.
So you also had ideas about the startup, right? So is it related to this topic or?
We can talk about another time. I'm looking into that as well. Yeah, it's in a way like using AI and lipids and how what we can learn from all this data, and like almost this dark matter of lipidology that nobody's looking at. I think there should be something that will be useful, given that it's like just not that targeted at the moment. I mean, most people, if you look currently, most people, if they work on AI and biology, right? Everybody's working protein folding, right? Or like some nucleic acid stuff, right? There's like the two big topics, right? But then the other two building blocks like carbohydrates and lipids are like a little bit ignored, right? and those are like both very highly technical fields, right? Sugars and glycans. That's like a very technical world, similar to lipidomics, right? It's like a very technical world. And yeah, but I always think those two disciplines, lipidomics and glycomics, are probably like where proteomics was 10, 15 years ago. So I think it's slowly time to start looking at building it, and then in the next decades there will be like a lot of progress and better understanding that then obviously feeds into this entire ecosystem of biology and giving a whole picture of what's actually happening.
Yeah, and from what I understood, also like we don't like research doesn't understand that much about lipids, right? Like we have more understanding about proteins, I guess.
Yeah, I think the protein space is much bigger. There's much more money flowing in, much more researchers, right? So yeah, I think there's like still to be a lot of things to be learned in lipids, and I think even if you look at it when you still go to university, right, and you do like your undergrad in biology, you learn a lot about proteins, and then they mention, hey, there are those lipids, right? I think there's also like it has to be like a change in education, right?
True, true. So in terms of your projects, because this is also, of course, very exciting, but you also have another exciting thing that you talked about. It's like those retreat, Los Alamos, Roatan, Zulu projects, right? Can you tell us a little bit about those projects as well? Like, can you give us a little bit insight of how it looks like, or like, yeah, what's the goal, and like, yeah,
what are you doing, guys?
Yeah, exactly. What are you doing, guys?
So I'm only involved in the periphery there, right? I mean, this is like the project of Niklas Anzinger and Lawrence Ion, and that they can go much more in depth about it. Um, um, I've just went there as like a visitor and helped organize a conference, and that's in a way my involvement on that. But yeah, I mean, currently it's just a gathering of very interesting people that try to push like the frontier of like how different cities and regulations could look like. And so I mean in Italia it's in Roatan in Honduras it's like this small island, 95% jungle, very pristine beaches, very nice underwater world. There are like a few resorts, and there's this special economic zone called Prospera. And they, in a way, negotiated with the Honduran government for the next 50 years. They have freedom on financial regulations and medical regulations, and I think almost all other laws except criminal law. And they are trying to start a new, or they are starting like a new city there that allows just more freedom for a lot of things, freedom for business, freedom for medical interventions. And given that the FDA and other um, regulatory bodies in the Western world are like very hard and very expensive to go through if you want to develop biomedicine. The idea is, okay, could we use Prospera and the district of Italia City to produce and test certain therapies faster, right, and cheaper, and thereby like accelerate this progress, right? I mean, that is instead of like 10, 15 years to get a drug to market, can we reduce it to 5 years, right? And maybe thereby be a example for the world and see, hey, there are like ways of how this can be done differently. And yeah, I mean, currently, I mean, when we were there, like there were like I think 200-300 people from the biotech, crypto, tech space, some companies, startups, um, people working there during the day, so talking, coming up with new ideas, doing science, but then also like a lot of fun things like getting together. I think there were like weekly bonfires, live music, swimming, snorkeling excursions, um, uh, early morning yoga classes. Um, so yeah, and it's a mix of like there are also like a bunch of artists. So it's the idea is like can you create like a community that has the goal of life extension as its core value and builds everything around that.
Since already you are mentioning crypto,
I also wondered what is the relationship actually, because it seems, yeah, a lot of people who are interested in crypto and decentralization, they are also very much interested in, yeah, aging research, longevity. So how does this, what's the history actually? How does this come about?
So I would think actually the counter question is why is every other section, why is traditional finance not interested in longevity, right? Why is like the
For
car
that,
industry not
yeah.
interested in longevity, right? I would think everything should be interested in longevity. But I think crypto probably comes a little bit more from this ethos of let's do things differently, right? And originally, I mean, you had Bitcoin, and the idea was, okay, the current financial system sucks. Can we do something better? That's how Bitcoin came into the world. A bunch of other coins, right? Just like in a way, decentralizing and taking power away from centralized institutions. And then if you looked at currently, most of science is in the hold of centralized institutions, right? All the funding comes from the NIH, comes from academia, maybe a few philanthropes, right? And they are, in a way, stagnant and mainly funding each other, right? And they're like very conservative and no moonshot funding. And then there's like this idea of like, well, can we extend lifespan and target aging, right? And that's like a bit of more ambitious goal. It's like a different paradigm. It's a different way of thinking about healthcare. And I think that just resonates with the crypto people of doing things differently in a way that that all this financial part of crypto and Bitcoin is like a counter thesis to the financial system. Longevity medicine or longevity biotech is like the counter thesis to traditional medicine and traditional biotech.
So I think, yeah, definitely when you mentioned FDA regulations are slow and yeah, everything like there is a traditional medicine, but don't you think that the general public also is kind of slow in accepting new treatments? Because, for example, you had like even all these protests against COVID vaccines, which wasn't like something that novel, like in a way, as what we are talking about, like completely changing bodies and so on. So do you think that it's also like that it would be accepted like overall in general society, it would also be a very slow process? Because I understand there are people who are very enthusiastic about anything that is new, but overall the public might be also slow in accepting, yeah, new ways of or new treatments.
Sure, but I think, I mean, that's obviously then the story that is being spun around, right? I mean, nobody in the public kind of has a problem with like cancer therapies, right? I think they're like, obviously there will always be people who have find something wrong, right? But I also think this will probably also like be rolled out slowly, right? It's not going to be like this, but then I mean, if there's like something that really works, people probably want to have it. That's my assumption. Or the other thing is that, and that might sound very anti-democratic, is it doesn't matter too much what the public wants. I mean, most of the public probably is not pro AI. Still, AI is everywhere, right? It's like if there's it's a small percentage of people who push those things forward, at least in Western countries, right? I mean, and then obviously you have like countries like Singapore, where it's like it's on their or like even the United Arab Emirates, right? They are very public about we want our population to live healthier longer, right? And we want to have it now. And that's how they just push it through, right? And I think hard to argue with that. I mean, the opposite was, well, we want to live our population to live shorter and more diseased. I think that's something probably nobody would get behind. And then also, I mean, I think obviously there's always this Western-centric view of like longevity. If you go to Asia, where you have like 2 billion people living or 3 billion people, longevity is like way more accepted there in from stories in the tales of like when I talk to some of my Chinese friends, they say, "Hey, did you hear about this guy who's lived 200 years on this mountain over there?" It's like, no, I haven't. Tell me more, right? So it's still way more accepted there, and even like the CEO of Fosun Pharmaceuticals, like the largest biotech in China, is talking about, well, we want to develop medicines that make people live to 120, right? Um, that's probably not much stuff you hear here in the West. I'm not sure what like if Pfizer would say that, what would happen. But I think it helps like to look a little bit outside of what the Western world is doing on that.
Yeah, that's true. That's definitely there are cultural differences. But then okay, in the still the Western world, who do you think then should be the advocates in a way for this? Like, because also maybe this comes back to the question how aware the general public is about these kind of things. Because I guess if you are a person, if someone is a person who is interested in technology and so on, so at some point they will kind of learn about aging, research, longevity is almost unavoidable. But if you're just not into those kind of things, then you may not be aware. So whose role is it to maybe, and publicizing is also like a tricky word because there's a lot of like, I don't know, even if you look at the research, that people have like scientists have arguments about things in the space, right? So like, is it the government that should be raising awareness about living healthier, longer lives? Is it the scientists who do science communication? Is it, I don't know, the technology entrepreneurs who seem to be very interested in that? So how does this work?
I think it's a combination of people, right? I mean, different messages resonate with different people. And I think probably everybody who wants to talk about it should probably talk about it and try to convince people that this is like something worth pursuing. And some people will like it and some people won't like it. Um, I guess it's probably like with everything.
And you personal yourself, like what do you, when you talk with people, what do you want to convey to them, or let's say what people should be taking out from this conversation?
I think probably the main thing is that people should understand that aging is malleable, that the aging process can be changed, and that is like that opens like a new avenue of developing therapeutics and living healthier longer. And it's an exciting field. If you're a scientist, it's exciting. It's like, I mean, it's like, why wouldn't you want to try to understand it? Why we age and how we can stop it, right? I think it's like, it's just a very hard problem to solve. And then I guess uh, I would think more and more people are getting aware of, but I mean, educate yourself about it, learn about it, and yeah, and start forming your own opinion and see how you can contribute to it.